I'm James Kobielus with IBM. This session was scheduled to be presented by Anjul Bambri, but yesterday Anjul took ill. She's got a fever. She'll be fine. But I worked with Anjul on the presentation, and so I was already planning to be at the Hadoop Summit, and it's a pleasure to be presenting on behalf of IBM on the topic that's very hot. In fact, it seems to be one of the core themes of this year's Hadoop Summit, of the marriage of Hadoop with data warehousing. And in fact, I just came from Mr. Tony Baer's session, the Ovum research analyst, on a very related topic, which was data stewardship challenges in data warehousing, based, using Hadoop for data warehousing, or data warehousing-like things. And of course, this morning, the Sears CTO's presentation was great, because he was discussing how they are, in fact, deploying Hadoop for a lot of data warehousing, single version of truth type applications. And also, that was a chief theme that I heard, we all heard Jeffrey Moore speak on, which is the notion of Hadoop increasingly being used to persist in manage and govern a system of record data. So I'm pleased to be presenting here. I'm a bit of a newbie to IBM. I'm known in other contexts. So I hope you'll be gentle on me, but I'm here to talk about vision, and really a vision that's driving a lot of your deployments of Hadoop, or will be before long, is the whole notion that Hadoop can be used as a platform for doing data warehousing type things like business intelligence, next generation business intelligence, as well as things that you've been doing in data warehousing for a long time, like ETL and data cleansing and the like. So what we see is that this is an evolutionary process for the industry as a whole, which is that Hadoop and traditional data warehousing are increasingly converging and merging and marrying into a new platform paradigm. And that paradigm is, we refer to it at IBM as the Hadoop Data Warehouse, or DW for short. So today what I'll do, in fact, I'm going to get off this podium because I don't like podiums or dioceses. I'm going to be at your level. And so I can see my slides better too. So today I'll be discussing in the next 40 minutes the drivers for this marriage of Hadoop and data warehousing, the 3 V's, or however many V's you want, and the myriad use cases that are driving adoption of various big data approaches, be they Hadoop, be they NoSQL, be they massively parallel data warehousing, be they lots of different things, Cassandra and the like. All this stuff you know, but I'll run through it because we need to provide the critical context in terms of applications. I'll talk about the diverse workloads that various big data approaches, platforms are handling. Data warehousing is doing, Hadoop is doing, other approaches, other hybrids of those and other approaches are handling. And then I'll use that then as to set the context, talking about this new platform paradigm, the Hadoop DW, and give a sense for how it's emerging, where it's in place now in terms of many of your implementations of Hadoop are in a data warehousing context already. I've seen this now for a couple of years developing. In my prior life as an industry analyst, I talked to plenty of CTOs and CIOs and data warehousing people who said, we are strongly getting into Hadoop because petascale, massively parallel data acquisition and cleansing and pre-processing, we need to do that on all this unstructured data, and Hadoop is the way to do it, or one of the key ways to do it. So, the 3 V's, there's 4 or 5, whatever, the volume, velocity, and variety. I'm sure that superstring theory will find at least 12 dimensions of V's, and they're all curled up inside these ones. But these are the main V's, the coordinate system for us to discuss. Requirements that, collectively we all refer to as big data. Petabytes of data coming in, streaming in real time, and in myriad formats from structured to unstructured. This is what's driving everybody towards various approaches. Now, big data is not, it has been, and Jeffrey Moore discussed the early adopters, pre-chasm, in finance and telecom and so forth. We're seeing business use cases for big data across the enterprise now. in, in different disciplines, in different business processes. Finance, marketing, a lot of social CRM, marketing campaign optimization. So we see it everywhere. We see Hadoop and data warehousing and other platforms being used for security incident and event management, for network operations, high performance, petascalable log analysis for things like anti-fraud. So the business use cases for big data generally and Hadoop as the key new approach for doing it are everywhere. And there are sponsors for big data at every level of the C-suite, from the CFO to the CMO to the Chief Information Security Officer and so forth. And more business mission-critical applications are riding on big data platforms. And really, if you look at the big data platforms, we have, as I've mentioned, as you know, clearly there's Hadoop, there's massively parallel data warehouses like IBM ISAS or Netezza or Oracle Exadata or, Teradata and so forth. You know all this. There's also things that we don't often associate with, unless we're reminded, with big data that are definitely part of the evolution of big data to handle more real-time applications. Stream computing. NoSQL approaches of various sorts are critical to handling all the unstructured, like document data. So there's a lot of different approaches that are subsumed under the heading of a big data platform, or can be. And clearly, they're handling a wide range of workloads. Increasingly, as you deploy big data platforms, you'll deploy platforms, be they cloud services, be they appliances, be they licensed software offerings that incorporate accelerators, which are prepackaged schemas, prepackaged propensity models, business rules, and so forth, that are all geared to helping you realize quick value, there's a V, on your next big data initiative, whatever it might be. So the notion of accelerators is critically important to delivering value in a big data initiative, regardless of the underlying platform or platforms you're using. Advanced analytic applications clearly is the sweet spot for Hadoop and other big leading-edge big data approaches. And in fact, last year's Hadoop Summit, I was in the Santa Clara event last year. That was definitely a advanced analytics and data scientist love fest. It was great. That was the early adoptions of Hadoop. This year, I can see a clear shift towards all that, plus, wow, Hadoop, you can do BI in Hadoop, you can do data warehousing in Hadoop, you can do ETL in Hadoop. The entire Hadoop ecosystem realizes now that Hadoop really is the nucleus of the next generation, enterprise data warehouse for this new age of the multiple Vs. So clearly, lots of mission-critical applications. And then, really data science, data scientists are the core developers for big data applications. And so data science is everywhere. It's on customers' lips. It's not only on customers' lips. Companies all over, everywhere, are establishing or building up their data science centers of excellence. Their statistical modelers, predictive modelers, MapReduce developers, and so forth. Because they recognize that those are the people that the experts, whether they be statistical experts or domain specialists, to use a term that I'm glad that Jeffrey Moore brought up this morning, are critically important to help you distill the intelligence, the insights from these petabytes, these blobs, I'm going to use a Tony Baer term, of data that you're managing in your Hadoop clusters. So it's all about discovering the sources that are available, empowering and entooling, is that a word? Entooling your teams of data scientists with the applications, the tools to be able to explore that data, that content from all different angles, to ask various questions, to look for relationships, to do graph analysis and the like, to be able to extract insights, to build models, MapReduce and so forth, to execute inside your big data platform. Data science, practical data science, it has come into the mainstream in companies all across the board. Everybody wants to be a data scientist, or if they do data scientist-like things, now more and more we see people sort of rebranding themselves in their careers as data scientists, and maybe the term is losing some degree of specificity, but if you look at this, the sheer number of new job listings for data scientists in, like, for example, Indeed.com, I saw some stats recently. The demand for this skill set is growing fast and furious. So really, data science initiatives are at the heart of leveraging your big data, no matter what approach you happen to be using under the covers. It's all about analyzing all the V's of information in motion, petabytes worth, discover and experiment, to be able to drill through petabytes quickly, and to run models and to refresh models constantly, iterate through them so that you can always have the best fit model in line to a given business process, like, for example, next best offer, that is maybe paying the way for your big data initiative. So fundamentally, big data initiatives, data science, critically important. And now what we're seeing more and more all over the world and among many IBM customers is that they're saying, we realize that we need to have a more expanded notion of the big data platform. Hadoop, yes, very, very important. And of course, our customers, many of them have evaluated or are using our big insights, but there's clearly many other distros and tools on the market, and I'm not here to necessarily to hard sell market IBM, but what we're seeing all over the industry, many industries, is that Hadoop is important for exploratory and iterative data science type applications of big data, and clearly that's all the, and I like the Sean Connolly terms yesterday, that's all the observational and interaction data, all the unstructured, the sensor data, the signal data. That's important, but that's only one piece of the overall puzzle, which is you still got all that valuable, and you need to drill through and correlate with this, all that structured, repeatable, as it were, linear data that you manage in your data warehouse. And you need to bring it all together into a unified platform or resource that your data scientists can explore as a collectivity. That's a real word. So really, the marriage of the established approach of data warehousing for doing data science, big data, and the emerging approaches, Hadoop, NoSQL, and so forth, is a real thing. The hybrid deployments of this plus that are everywhere. And clearly, we've heard a number of them this morning, and you're probably doing a lot of different hybridizations of these various approaches inside your big data initiatives. So what I'm talking about today, the marriage of Hadoop and data warehousing, has already, in many ways, not only it's been consummated. I'm not going to extend that metaphor any further. It's been consummated inside your operations, inside your data science initiatives. And clearly, the killer apps for all manner of next generation data science and big data, this is the meat and potatoes that you live by. Clearly, it's and it leverages all the 3 V's: continuous social media monitoring and analytics. It's harvesting intelligence from the low-hanging fruit, which is all of the Twitter and Facebook and other social customer intelligence that's just there for the taking, drive it into your marketing and your next best offer and your customer experience optimization. That's everywhere. Excuse me, real time. Multi-structured. Correlate it with historical data so you can get a better sense for how your existing customers, what their propensities are to buy or not buy the product you're launching. Content mining, natural language processing, classification, clearly. The social universe is primarily unstructured, human-generated data on their feelings and activities and so forth and so on. And NLP is absolutely essential, and clearly so many Hadoop clusters do NLP as their core function to extract intelligence from all these sources and deliver it down into a structured format, maybe into an RDBMS or to a data warehouse, into an OLAP cube, for you to do further analysis. Entity extraction and integration will be increasingly important as you're trying to correlate what people are tweeting about, with what your current customers or your prospects have bought from you in the past. And so entity integration is the ability, one of the things it refers to is the ability to correlate identity information, name and address information across disparate sources. Entity extraction and integration, critically important if you want to do target marketing in a big data context. And that demands a fair degree of unstructured sources, all the, the new social intelligence, with structured sources, your CRM system, your customer database. Statistical analysis, predictive modeling, machine learning. You know this. You live and die by this. This is the heart and soul of data science. Heck, machine learning is like super hot. I tried to get in like everybody else to that Twitter session yesterday, and I arrived just a bit too late. Machine learning. I mean, machine learning is about the most compute-intensive and complex set of advanced analytics that you can be running right now inside your Hadoop cluster, and everybody's going towards Mahout and so forth. And of course, we at IBM have a library called SystemML inside of Big Insights, and I won't say any more about that. You can always download these slides and ask us offline. Targeted e-commerce, next best action. Clearly, Hadoop clusters are being used everywhere for marketing campaign optimization and next best offer and customer segmentation. So you can tune your offers and promos and responses and in real time or close to it to customers based on historical data, based on what they're doing now, what they're clicking on in your portal, and what they're likely to do, you know, based on propensity models, predictive models that are in line to a recommendation engine that might be driving call center scripts that your agent is reading from, or might be driving the offers that are presented in real time inside the portal experience. Predictive complex event processing, this is real time, clearly, by the very nature of it, and so that's the velocity on steroids that clearly is it's the area that often we overlook. I mean, when I say we, if you're a traditional, there's no such thing as a traditional Hadooper, but you know, Hadoop historically really strong on batch. We're going far along as an industry and many users in terms of real-time Hadoop with HBase and Cassandra and so forth and so on. So complex event processing applications are coming into Hadoop everywhere. And of course, we have InfoSphere streams. That's part of our overall big data platform. It can execute MapReduce models, just as Big Insights can. Intent and sentiment analysis, I'm not going to belabor this point, but clearly this is social media. This is correlating disparate streams and historical data to be able to identify people's awareness and propensities to buy or not buy, or to recommend or not recommend your product. So you know all that, but I wanted to give you that background once again, because really, clearly, you can see that right now. This broad range of very real use cases and applications of big data already in the real world leverages multiple platforms quite often. Data warehouse, Hadoop, NoSQL, and so forth. And the range of innovative NoSQL and NewSQL and whatnot approaches will continue to proliferate. But really to only slightly oversimplify what's going on, that data warehousing and Hadoop, as it were, rule the roost in big data. Those are the dominant platforms or dominant approaches. And they're very similar in many ways in terms of the broad architectural approaches. When I talk about data warehousing, I'm talking about the latest generation of massively parallel data warehouses, managing structured data and used for in-database analytics. So keep that in mind. The term DW refers to a lot of everything that's in ISAS or Oracle or Vertica or whatever Microsoft parallel data warehouse, whatever you happen to use. And Hadoop are similar in the sense that they have common architectures and common architectural approaches at the highest level. They have what I call cloud-facing architectures, which is the extreme scalability on the various Vs. Is right there, the ability to have pluggable storage engines inside in a common architecture to varying degrees depending on the platform. Increasingly, data warehouses support virtualization of data through an abstraction or semantic layer. So there's a lot of things in data warehousing that are similar in a broad way to what Hadoop has been from the start architected on. The massively parallel processing is the key, obviously, for extreme scale-out in both contexts. In database analytics is key because, whether it's Hadoop or data warehousing, you can and probably are running more and more analytic logic in terms of segmentation or regression and machine learning and so forth, executing inside your data warehouse and inside your Hadoop cluster, and possibly, your days are spent figuring out what job or what model is optimally run on which platform. It's increasingly getting blurry as to the distinctions between these two platforms, and as Hadoop comes into more and more of our data warehousing platforms in terms of integration of the technologies, not only data passing, but in terms of sort of load balancing and job scheduling across them. The distinctions will blur. This is all becoming very much a more of a unified application server, the big data platform for doing both advanced analytics and also transactional applications in a common fabric. Mixed workload management, because this new big data world is very much built on a growing range of workloads of all sorts with different latency requirements and different SLAs and so forth, being managed with a common set of policy tools and resource management applications. And then the whole notion of hybrid storage layers, that the big data platform of today and tomorrow is not just unstructured, it's not just structured, it's all of that. It's new storage engines and data persistence approaches, including things like in-memory, petascalable, in-memory analytics from end to end. So really the whole notion of pluggable hybrid storage layers across this cloud-facing architecture. Data warehousing and Hadoop in many ways are evolving, converging on that common, based on that common set of approaches that we find already in many commercial products, including IBM's. So, Hadoop is the core of the next generation big data warehouse. To hit on the core theme again, which is that Hadoop, what's revolutionary about Hadoop is a number of things. It's the first vendor-agnostic framework for doing MPP and advanced analytics against polystructured or multi-structured data. Of course, the MapReduce is the first extensible framework that allows you to build advanced analytics and data management functions and then execute them in massive parallelism within this cloud-facing architecture. And clearly, Hadoop is evolving rapidly in every new direction. This entire ecosystem, this Hadoop ecosystem, continues to grow by leaps and bounds from last year to this year. It's like it's a different industry. And next year, it'll be quite different further. And clearly, Hadoop is just one piece of a broader big data fabric that can, there's lots of innovators in this room, I'm sure, at this conference who are pushing it in all these directions. It's being commercialized and adopted everywhere. Hadoop is a mass phenomenon all the world over. In the past few years, I've had people I haven't seen in 30 years from high school and college saying, hey, you know a thing or two about Hadoop. We're doing Hadoop. Maybe you can share with us your great expertise on it. It's like everybody's screaming for expertise. Everybody is educating themselves on Hadoop because they know that this is the future. You know that, but it's very real, and clearly it's an extraordinarily vibrant open source community and industry. And look at Hadoop Summit. It's testament to that. So really what we're looking at as the big data platform of now and going forward is in many ways, if you look at Hadoop, where Hadoop clearly, its sweet spot, and I've heard this said in a number of contexts at this event, including yesterday in the keynote, Hadoop is being used in many companies as the big data refinery. It's the data acquisition and discovery and pre-processing and staging layer sitting behind a single version of truth repository, aka a data warehouse, usually running an RDBMS. And quite often we see in these hybrid deploys that there'll be Hadoop and various NoSQL platforms like in graph databases feeding a data warehouse or maybe feeding directly downstream to an in-memory platform for further analysis, to a columnar database, to an OLAP star schema, so forth and so on in various and sundry hybrid combinations. This is real. I mean, so clearly, Hadoop's sweet spot right now is exactly what I laid out, the whole notion of a big data refinery, a petascalable refinery that's optimized for all the unstructured stuff that is really, truly the new world of business intelligence. But data warehouses and data marts and ODS platforms and all that you've invested in are not going away. They simply need to play more and more with Hadoop, and Hadoop needs to play with them. And clearly, what we're seeing at this show and ongoing is that we as an industry are recognizing that requirement, and we are evolving our solutions, and clearly IBM is as well. And so the notion of a single version of big data. Tony Baer presented on the whole notion of data stewardship in Hadoop for data warehousing type applications just before this session. It was really good. Tony always does a great job. So, the whole notion of a data warehouse, it's an old buggy whip term that we have, but, what is really fundamentally the core function of a data warehouse? It's the single version of truth repository of your system of record data that you do your BI, your reporting, your query, your in-database analytics, and so forth, and so on. So the whole notion of a single version of big data, well, do you need a single version of all this unstructured information, this new stuff, this signal data, this clickstream data, this tweets and so forth? You have to stop and think about that for a second. A business builds controls around a given data set like customer data and finance data because you need to maintain a gospel record that you run the business on. Do you really need to link somebody's clicks in your portal to their customer record? Is that something that makes sense? Probably not. Likewise, is there a single version of somebody's tweet that you need to maintain? No, actually, I think what we're seeing is that there will be increasingly some unstructured sources that you want to link to official, say, customer records. But for the most part, all of that unstructured stuff, lots of the new stuff, what it really is that a lot of it's, as it were, individual datums are garbage. It's only the patterns that you're distilling from all of the people's visits to your website or from the pattern of stuff that they're saying on Twitter. It's the patterns that are important, and that's why you're doing data science. That's what you're looking for. So essentially, you're ingesting all this junk, and out of that comes the gold of the patterns, and the patterns are what you increasingly want to manage as a key business resource to drive things like customer segmentation and customer experience optimization and so forth. So yes, there will be more. Hadoop is coming inside of data warehouse architecture, so you're going to want to do more data governance in platforms that incorporate aspects of Hadoop like MapReduce and Hive and HDFS. But still, I think for the foreseeable future, the vast majority of the data science applications and social media analytics, you're not necessarily going to need to do a single version of. But since Hadoop is coming into the data warehousing ecosystem fast and furious, definitely we're going to see MDM and data quality, data profiling tools be adapted, be evolved to support a single version of unstructured sources as those business needs emerge. And things like data discovery. We acquired a company called Vivissimo just recently that does data discovery and data profiling for big data. And so clearly that's the kind of tool that you're going to need going forward as you move your Hadoop clusters into more of these single version of truth type applications. So these are really busy slides you can download later on from the site when they put it up there. So in terms of Hadoop DW integration, the things you should be looking for now in terms of current products are exactly roughly what I have up here, which is that many others provide very sophisticated Hadoop distros that have got all the core sub-projects and so forth. HDFS connectors, everybody has them. That's critically important, bidirectional, to move data between Hadoop clusters and data warehouses and so forth and so on. But also, you need clearly the ability to do modeling and management acceleration and optimization of MapReduce and other jobs they're going to execute inside of Hadoop and so forth, real time, robust availability, security, and workload management. You can't really run a 24/7 data warehousing type application on Hadoop if you don't have all the robustness, including data governance and MDM tools as they emerge. So we as an industry are developing and evolving the broad range of modeling and management and governance and security tools for Hadoop to make it ready for these types of applications as they emerge. We're not all there yet, but next year I'm sure that There will be plenty of new stuff on the market from various vendors, established and emerging, to help flesh out the DW-ready Hadoop ecosystem. So really, platform accelerators for Hadoop, and for data warehousing and other applications are critically important to help you realize quick value. One of the things that we all are, as an industry, are trying to get, we're all working on our packaging in terms of, I think it was Jeffrey this morning said something along the lines of, right now we're still in the platforms and tools and sort of like the plumbing. He didn't say plumbing, but I felt it. Level of putting out this technology. We don't really yet, as an industry, have Hadoopicized solutions, business applications fully put together for quick deployment, quick value. I know that's coming. We and many others are focusing on that in these and all the other areas where Hadoop is already being adopted. Like I said, MDM is critically important for the future of the Hadoop DW. To be able to do the governance, the discovery, the management of multi-structured data in Hadoop clusters. And I'll just flip beyond this because this is fairly busy and you can study it offline. And this is where I get the closest that we have here to a marketing slide. But this is just simply to show that IBM's Big Data Platform already, we have Hadoop, we have Big Insights. We have, for the velocity, we have InfoSphere streams, which you can execute, map, reduce. And we have data warehouses. We have Netezza and ISAS, and of course, we have a MapReduce library inside of Netezza Analytics. And so really, fundamentally, that ecosystem I fleshed out in terms of making Hadoop capable of deployment into more data warehousing type applications. It depends on a lot of these layers of functionality that we and many of our competitors also are developing. So bear in mind that clearly the whole notion of a big data platform is much larger than Hadoop. You know that that's a key theme now we all recognize. And this is an exciting industry and an exciting time to be in the industry because this is all emerging. In the next 5 years, I expect the vast majority of data warehousing applications to have significant footprint of Hadoop inside to manage all these new unstructured sources that are really driving many investments in this technology. And now I have about 10 minutes to take questions.
James, thank you for the presentation. In one of the slide deck, you had traditional data warehouse on the left with OLTP and other stuff. And on the right-hand side, you had Hadoop. In between, you had the enterprise integration. Can you elaborate a little bit more on that? And I'll also give you a use case. So let's say on the right side, on the left side, sorry, you have your customer data and transaction data, and on the right, which is the Hadoop, you have analysis data, customer behavior analytics data. And as a company, if we want to do analysis on combined data set, do you recommend moving all the data to Hadoop and back into data warehouse, or have another, place where you dump all the data together? So what does that middle piece look like?
Whoa, now I'm on the firing line here. Okay, what's that convergence point of a Venn diagram? What does that subsume? Well, it's data sharing, obviously, data movement. It's also being able to move jobs back and forth to execute on the optimal platform, to maintain SLAs and so forth. Clearly, it's also, to some degree, unified metadata. Like Ambari, for example, not Ambari, HCatalog, I'm sorry. HCatalog is a potential piece of that convergence point if it's adopted fairly broadly across the industry to manage, in a broader metadata context, to be able to support lineage analysis and impact analysis in terms of modeling functions, in terms of data movement and data management across complex hybrid DW, NoSQL, and Hadoop deploys. So really, enterprise integration is a big catch-all term for all of the middleware and modeling and management fabric that we need to implement to bring these platforms truly together into more of an Uber platform. So what was the second question, or the second part of your question?
The second part of the question was, in order for a company to analyze the data sets combined together, because if you're just running normal reporting, you could very well do it on the DW side.
Yeah.
And if you're just doing customer behavior analytics, you could very well do it in the Hadoop side. But if you want to kind of combine them together, what strategy or what is the best approach so far based on technology we have right now? What is the best way to go about it?
Whoa. That's a tough question. So really, in terms of combining them, I'm going to punt on that. I have to think about it. Take that up with me offline.
Sure.
I have no pat answer on that. I have to think about the various layers of that one. Thank you.
If you don't mind, can I hit you with another question then?
Sure.
You did touch on data governance. Can you elaborate a little bit more on that? And these are actually challenges that I'm facing right now. So.
Sure. Well, one aspect of data governance is, first of all, figuring out what not to put in your Hadoop cluster as a sandbox, as an exploratory sandbox. You can easily fill it up and go. You can go full Yahoo and have what is it, 40,000 nodes and how many petabytes of data from every click on every portal you might have. Every log entry going back 10 years and so forth. So really, a big part of governance is discovery and profiling. What actually is out there? What do you actually need to, what do your data scientists need to explore? What controls are necessary around the schemas of that data inside of those different data sources inside your Hadoop cluster? What stewardship or exception handling processes are necessary to manage versions of that data inside your Hadoop cluster? In other words, all the traditional data stewardship stuff, critically important. But really, fundamentally, if you think about the whole notion of a dump, just dumping data in there. One of the strengths of Hadoop is it's, the HDFS. You can just dump everything and then explore it later. You don't need to have all the answers up front about what to keep and what not to keep. But at a certain point, you're going to max out your storage budget. Your storage budget is going to be 100% of your IT budget, and you'll have no money left for anything else. So clearly, you're always going to still need to make, until storage is free, you're still literally free, you're going to need to ration storage to just the critical data sets. That's the number one thing to consider right now in terms of data governance in a Hadoop DW context, especially for exploratory data analysis. Okay, 2 minutes left. I'll take one more question.
Just following up your earlier comments on the last year's summit and this year's, and then the type of vendors, would you mind comment on the vendor ecosystem, especially with the various, the application layer, the infrastructure layer with the data infrastructure, the management layer, and what you see as the trend moving forward, as well as the challenges for all those vendors to cross the chasm?
One of the key trends is, that's great. So the segmentation within the Hadoop ecosystem continues to grow in terms of. Last year, the segmentation of the industry in terms of, there were the distro vendors, there were some modeling tool vendors, that was their focus. There were just a few data integration vendors in the market with commercial solutions, so forth. This year, we see more vendors in each of those segments. We see more segments opening up. Last year, there was hardly anybody who was focused on BI in Hadoop. This year, there's at least, 7, 8 vendors now that do BI or have adapted or built BI solutions or BI-like solutions to tap into Apache or Cloudera or Big Insights or whatnot. So we're seeing, in a sense, that's the democratization of Hadoop in the marketplace. It's becoming adopted more widely, or will be, if things like BI. If the next generation of BI is being built. Right? And so, you look at all the startups here in the Valley, there's a lot of BI startups in this space that weren't here. I met a few offline last year, but now they're actually out of stealth mode. So, really, that's going forward. Just expect to see the Hadoop ecosystem, now the sheer number and range of vendors and the segmentation of those vendors, and clearly all the mergers and acquisitions will proceed apace. IBM will undoubtedly, and Oracle and SAP and others. Clearly there will be consolidations, and as everybody tries to put together a big bad Hadoop platform and tool portfolio with full governance and everything. So clearly we're at a stage right now of a market that's not mature but is rapidly maturing, and there will be. I wouldn't even say we're due for a shakeout. I just say we're due for further platformization by incumbent vendors and by other vendors who are up and coming. And with that, I think I have to close it off because I think that's the end of my time. Thank you very much for attending.